see, this is a display board that I have kept at my home, and whatever topic is interested to me, I prepare the display board and I decorate it. So today I will decorate it with the topic circles, as this topic I have taken for standard 9, and I hope all the students of standard 9, when you study this chapter, when you are going through this chapter, you will also decorate your display board. You must purchase a display board if you don't have. And see, I have made circles. I have written, you will write in your own style, and then I have a cutout of circle and mark the center point and taken a scale. Now I will measure. So now you can see the scale is placed here, and the diameter is the line segment passing through the center, and from 0 to 20, that means the diameter is 20 centimeter, and there are infinite diameters which pass through the center, because from every point infinite lines can be drawn. So from all side it is coming 20 cm, which is showing that this is a perfect circle. You can see every side, if a line is passing through the center, it's a diameter, and the length is 20 centimeter. Now I will take two threads whose length will be equal but less than 20 cm. Two threads exactly equal in length, and the length of thread is less than 20 centimeter. That is the length of diameter. This must be less than length of diameter, then only we can make it or use it as a chord. Now we will check. We will have to check exactly which place we can paste it. So its end point must be at the end point of the circle. So this must be the end points must be at circle, touching the circle. So only the boundary is considered as circle. So I'll fix it here, so that exact length, its end points must touch the circle. So we will paste it here, and the same we will find it a right place where we can place it, that the end point must touch the circle. So we will fix it with Fevicol. So now you see, I have fixed both the threads. Now I'll show you, are they actually equal in length or not. So we can measure this by this ruler. We place at 0, and now here you can see this is coming 19 centimeter. And so again measure this one. We will have to properly keep it. This is again, you can see, coming 19 centimeter. So length of both the threads are 19 centimeter, means they are equal in length. So now what is our main experiment? We are going to check its distance from the center. So do you know what is this apparatus known as? Instrument. This measuring tool, this is instrument that we have in our geometry box called square set. For that we have to check whether the perpendicular line from the center to the chord, what is the length, we can measure using this square set. So how we place? We place upon the chord like this, okay, and we slide it towards center side, and then coming to measure. Now we will measure it. At the center you will see what is the length from the center to the chord. So this is perpendicular line. The perpendicular line, as this is 90 degree here, you can see by the square set, you can see this is 90 degree, and from the center, at center it is coming 3.5 centimeter. That means the length is from here, it is 0 to this point is 3.5. So the length of this chord is 3.5. The same way we will do for this thread. Now we will slide it like this from the second thread, and we'll reach to the center. So again you can check, this is perpendicular, and this is thread, and the perpendicular distance of this thread from the center is again 3.5. So when you have kept it like this was coming 3.5. from the first chord and from the second chord. So here you can conclude that from both the chords, both the chords are equidistant from the center. So when the chords are equal in length, they are equidistant. That means when the chord was 19, both the chords were 19 centimeter and the diameter was 20 centimeter and the distance of both the chords were 3.5. So in whatever manner you place these two threads, you will get always the distance 3.5. Means two chords will always be at equal distance from the center. So this is the part we have experimented with the circle and thread, and we will place it on our display board, and also we will have the proof of this. We will prove it by using the congruency. Now children, see, I have some stripes and have written something on it. Now I have to arrange it according to our experiment we have done in mathematics on circle. When chords are equal, they are equidistant from the center, and we can also use it in converse way. So let's arrange. So see, what are these? From the center, chords equidistant from are equal. Equal chords are the center of a circle and equidistant. So let's arrange. So I think first of all we have equal chords. So we place it here. Equal chords are, yes, correct. Equal chords are equidistant. So yeah, equidistant. So we place it next to equal chords are equidistant. Equal chords are equidistant from the center of circle. What it should be? From the center. So now we have the first statement ready of this theorem. Equal chords are equidistant from the center. Right. And now the second one, if the chords are equidistant, then the chords are equal. So chords equidistant from are equal? No, from the center of a circle are equal. Yes, right. So we have to arrange it like next. First is chords equidistant from the center of a circle are equal. Means when chords are equidistant from the center of a circle, they are equal. Right. So we have arranged both. Equal chords are equidistant from the center. Means if chords are equal, they are equidistant. And the converse of it is, if chords are equidistant, means any two chords, we don't know the lengths, and if they are equidistant, means distances are known, we can say that they are equal. So when we have then that chords are at equal distances, they are equal. And the main theorem is, if chords are equidistant from the center, means chords are equal, then they are equidistant. If chords are equidistant, then they are equal. So these things you have to understand. We use it in two ways, the first theorem and its converse. Both are same by the concept, but only written in two ways and solved in two different ways. Now students, see how I have placed the circle over this, and now I can rotate it over the sheet. And now see, chords can be in any direction, any way, because it can be rotated. When you will read any picture or images about the chord can be like this or chord can be like this, but you will always find out where is center and its distance is perpendicular, and in every way you will find out that when they are equal, their distance will be equal. So either this is kept like this or like this, they are always equal at equal distance from the center. Right?